In this part, we'll talk about Newton's second law as in terms of linear momentum. So we'll see that the summation of F external will be equal to dp over dt, and this is what you call the derivative of the linear momentum with respect to time, or it's equal to delta p over delta t in terms of a big interval of time. هلا, how to verify كيف بنبين هيدا? So as we know, summation of external is equals to ma. This is Newton's second law. Now we know that a is equals to dv over dt, is the derivative of the velocity, which can be written also in the form of, since m is a constant, كمان هيك في دخلها لجوا, I can put it inside, so it will be dmv over dt. Now who's m times v vector? M times v vector, this is p, so it's the derivative of p with respect to time. So هيك بنوصل that the summation of F external can be written in the forms of dp over dt. Now, here, sometimes the question is to find, you have force, you have the forces, but the question is to find the linear momentum p. So if the summation of F external, the net force, is equals to dp over dt, this means I can do the antiderivative in order to find p, which means that p is equals to F external dt, the antiderivative. Now here we can do it along x or along y, according to the motion, and sometimes we will do it along x and y, for example, in the case of a projectile. So now we'll do a small application. A particle of mass m is equal to 4 kilogram is launched with a speed of 3 meters per second on an inclined plane, making an angle of alpha equal 30 degrees with the horizontal. And you have the forces of friction. أكيد هلا أفضل شيء we trace a figure. So you have an inclined plane. It's launched with a speed of 3 meters per second. This is V on an inclined plane, making an angle alpha is equal to 30 degrees. And you have the frictional force. So we can trace, for example, here the particle. First, we represent, the question is determine the linear momentum of the particle in terms of time. So we know that according to Newton's second law, the summation of F external is equals to dp over dt. Now ليه كتبتها dp over dt وما كتبتها ma? Since the question is find the linear momentum. ما بدنا ننسى the steps of the Newton's second law, ولا هن we trace the forces, we represent the axis, x-axis, we trace the forces, we have the weight, we have the normal, and we have the frictional force, which is opposite, and then we apply Newton's second law. So we'll have friction plus weight plus normal is equals to dp over dt. And then in the next step, so it's the projection. هنشيل الفector, so بناخد the projection on the x-axis since it's moving on x. So by projection, we'll have minus f, we'll have minus mg sine alpha, and the projection of the normal is 0, which will be equals to dp over dt. And now I have the values, so we'll have that dp over dt is equals to minus f, this means minus 2, and here we have minus mg sine alpha, so it will be m times g, which is equals to 40 times sine alpha, so minus 40 sine 30. Okay, so we'll have as answer, it's equals to 20 here sine 30, so it's 10, so it's minus 10 and minus 2, so it's minus 12 here. Then now the question is to find p. This is dp over dt, so this implies that p, I can do antiderivative both sides, so it will be dp is equals to 12 dt. So by antiderivative, we'll have that p is equals to 12t plus, we don't forget p0. Now, P0 is the linear momentum at the initial time, which we can find it. It's launched with the speed of 3 meters per second. So we have V0. So I can say here that P0 is equals to M times V0, which is equals to 4 times 3 equals to 12. وهيك بيطلع عنا that P is equal, so sorry, this is minus 12 here. It's minus. So we'll have minus 12t and plus 12. So this is here minus 12. This will be P in terms of time. وهيك إذا قلنا بده for example the linear momentum at t equal 2 seconds, I can find it at t equal 3 seconds, I can find it, and etc.